let's implement Boids. Boids, basically Boids. They say Boids is an artificial life program developed by Craig Reynolds. Blah blah blah. So basically it's an algorithm which emulates some kind of emergent behavior. And emergent, what does it mean? Emergence. Yeah, basically if you have some kind of set of simple rules and you apply these rules to some entities, snowflakes, or maybe some objects in space, the new kind of behavior emerges from these simple ones. And you can apply different types of behavior. It could be simple ones, it could be more complex kind of behaviors, and whatnot. And in Boids example, the author of this algorithm provides these three moving forces, main moving forces for the Boids. So they say that Boids have a separation force. So it's some kind of a force which pushes Boid from its neighbors. It's some kind of alignment force which aligns Boid velocity towards the velocity of the nearest Boids. And cohesion force which pushes the Boid towards the group center of mass. And you can see that, for example, cohesion force and separation force, they kind of contradict each other, because separation force want to separate Boids and cohesion force want to group them up. But this is the point, that you need to come up with some kind of forces, some kind of external forces on the system, and you need to balance up these forces between each other. And after that, these forces in combination will provide some kind of so-called emergent behavior. So let's try to implement at least these simple rules. Yeah. Let me create a project directory, make directory Boids demo. Let's call it Boids demo. cd Boids demo. Let me download raylib GitHub. I just download zip archive of the latest raylib version. I already have it in my download folder. Let me just copy it. cp raylib here, unzip it, remove the archive, raylib zip, and let's just build it. On Linux you can just call make in the src directory, and this will effectively build the library. Okay, while it's building, I will create basic project structure. Let me create src directory. Let me create include directory where I put my my header files, and let me create lib directory where I put just built raylib library. Let me just copy it, raylib src lib raylib into the lib directory. Also, let me copy header files. What do I need? raylib.h into the include directory. I need railgl. I need give me a second. I need air camera here, and I need ray math in here. Okay. I suppose I don't need raylib source directory anymore. Raylib master remove. Okay. Also, I need to create compile flux txt file. This file is just for me. You don't need this file. It's just for my editor to understand where to find the include files. And also, I want to copy maybe from my previous projects. Yeah, from here. Clang format here. Clang format is just a set of formatting rules. It's probably you don't need it as well. It's just for me. Okay. Let me init git repository right away. All right. Let me create main.c void main void, not void, int printf hello who, hello boids /n. Let's build it. GCC, I want to output it here, Boids demo, and I want to build everything in the source directory with extension C. Okay, it's compiled successfully. Now let's maybe implement basic hello world using raylib. Well, as you know, in raylib, hello world means that you need to draw at least a circle in the center of the screen. So let me include raylib. Let me initialize the window with screen width and screen height, and title Boids. Boids what? Boids demo. Okay, let me define this stuff. Define screen width 1024, screen height 1024. Let me set target FPS, set target FPS 60, and also let me turn on set config flux MSA for X hint, for the simplest anti-aliasing you may have in OpenGL. Okay, and let's write the main loop while window should not be closed. I just begin drawing and drawing. Begin mod 2D camera and mod 2D here, and draw a circle. Let me quickly create the camera. I will make it static camera 2D camera. In raylib, camera 2D is just an alias for but maybe it's not. No, I think it's like div camera. I don't know, doesn't matter. Camera is equal, what do I need here? I need offset. Let's set offset to the half of the screen. Screen width 0.5, screen height. What target? Target is just the center of the screen. Rotation, we don't need the rotation here. and zoom, I don't know, let's say 10, I don't know, we will tune it later. Okay, and let's draw a circle. Draw a circle vector. Center is just the center of the screen. Vector to 0. I need to include ray mass. Radius, let's say 1. And color, let's say red. Okay. And let's close the window at the very end. Now, okay, let's try to build this. Okay, we need to add include directory. Include. We need to link against the raylib. Let me set the library directory lib and link against raylib. Raylib. Also, we need to link against lp thread and lmass and ldl. Yes, yes. Okay. Boids demo. Yeah, nice. Looks perfect. Looks perfect. Let me grab this command and put it in the simplest in the world make file. Make file. It will be simplest in the world make file. Output here. Sources here. Include this one and this one and libraries, and also let me set warnings all. All right, let's try to make it. Make success make. Let me remove the old executable. Make and rebuild it. Make and run Boids demo. Okay, looks perfect, looks perfect. So now we are ready to start implementing Boids. Let me quickly factor out this initialization stuff. Void load void. Let me factor out drawing function. Draw in here. Draw load. Well, and let me factor out this one. Unload. Void unload. Void. Okay, and let's create the update function. Empty for now. Okay, let's check that everything is working. Yes. All right. How can we even start to implement Boids? Let's maybe create the basic structure of a Boid. Type def struct Boid. And let's think what kind of properties Boid should have. So it definitely should have position. Position vector 2 position. It definitely should have velocity because we want to operate upon this velocity. We want to modify it, we want to track it, and eventually we want to at the end of each frame, better to say, at each frame we want to take the change of the position from this velocity and apply it to our position. So we need velocity. Vector to velocity. What else do we need? Maybe let's say some geometric properties, like for example radius. Do we need set color? Yeah, let's say maybe not. Let's say yeah, maybe let's set color. color. No, I don't want set color. Let's keep it simple for now. What else do we need? Maybe that's it. Maybe that's it. And I will store all the boids in one static array. Because as you know, C doesn't provide us any sort of dynamic arrays. So we kind of need to implement our own container, basic container structure. Static boids, max and boids. And max and boids is just the maximum number of boids possible in our application. Let's say 300, for example. And let's say I want to spawn the boid. How can I spawn new boid? Let's create void function spawn boid. And in order to spawn the boid, I want to provide vector to position, velocity. No, I won't provide. Let's just provide just position. Simply provide just position. Spawn boid, and I need to find the available slot in this array to put new boid into. There could be several different approaches to this. Basically, you can create your own dynamic array, you can create your own, for example, maybe hash set. But I prefer, in simple cases, I prefer to use just simple iteration. Let's just iterate over all the boids while I is less than max and boids plus I. And let's just check if the slot is available. Boid pointer to boid is equal to boids I. If boid is spawned, I just continue because this slot is occupied. For example, bool is spawned. Yeah. Yes, and I understand that this kind of spawning function takes O of n time, where n is the maximum number of boids, and it's okay. It just doesn't matter because we only have 300 of boids, and spawning of each boid will be very quick. It's not a problem. And also, I'm not planning to kill the boids in my application, so I will just spawn them right away, and that's it. Anyway, we spawn the boid, and let's just set its properties. It's spawned, yes, it's spawned. Then boid's position is equal to position. Boid radius is equal to, let's say, 0.1. Maybe boid radius. Let me just put it for now here. Static float boid radius 0.1. And static color boid color. Well, it's obvious that it's all about boid, so I can just remove boid word from the naming of the variables, of the constants. Static, let's also make them constant. Color is equal to, let's say, ray white. Ray white. Radius is radius. Boid color. I don't have a color. Let's set a color. It's not a big deal. Color. Boid color is equal to color. Okay. Yeah. And we can simply return the index. I don't know do we need this index or don't we? But let's just return it. Just in case, let's return it. Yeah, integer. And if this function returns -1, it means that we cannot spawn the Boid, and we can handle this case if we need to. But I don't think that we need. Spawn Boid, okay. And let's maybe spawn the Boids in the load function. Here we load window, load Boids. And let's just simply initialize all the Boids for int I is equal to 0, I less than max and Boids plus I will spawn the Boid, position. And yes, I also understand that that this loop now takes n square time, because we iterate over all the Boids here, and also we iterate over all the Boids in here, so it's n square, where n is the maximum number of Boids, but it's okay, it just doesn't matter. Even if we have 1000 Boids, it's also okay, it's not a huge deal. Position, let's say that vector2 position is 0 for now, 0, and we just spawn the Boid. Yes. Okay, but we don't have any function to draw the Boids, so let's implement this one. Instead of drawing circle, let's maybe draw Boids. Draw Boids, void, and let's iterate for int I is equal 0, I is less than max and Boids plus I, Boid, pointer to Boid is Boids I, and let's just check that this Boid is alive. If Boid is not spawned, we just continue. And again, it's okay to have this kind of linear complexity in your application if you have small number of entities, small number of objects that you iterate on. We have only 300 of Boids. You can use linear iteration everywhere. It's okay, it's all right. So we just spawn Boid. Oh, sorry, we just iterate over all Boids. We take Boid, we checked if it's not spawned, we continue, and if it's spawned, we can draw it. If it's spawned, we can draw it. Boid, let's draw circle. No, I don't like this function. Circle v. Center will be at Boid position. Radius will be Boid radius, and color will be Boid color. That's it. And we don't need to set camera here, like begin mode 2D camera and whatnot, because we already in this context. So I prefer to develop these inner draw functions without any sort of begins, like begin drawing or begin mode 2D. I prefer to keep them out of these functions. Okay, draw Boids, and let's maybe run this. Yeah. Maybe it's too small. 0.1 radius. Let's say 1. Yeah. Maybe let's decrease zoom. Should I increase it or 5? Yeah. Now it's perfect. Okay, but as you can see, we have 300 of boids, and all these boids are just placed in the center of the screen. It's not fine. It's not okay. It's not okay. Let's maybe offset the boids. Let me think. Let's maybe implement right away the first force, separation force. So basically, we can spawn the boids maybe with some offset from the center to add some randomness of their starting position. But let's maybe try to handle this case without this randomness, and we will try just to implement separation force, and we'll see what's happening. What will happen in this case? Will they separate from each other? Spawn void. How can we? Where can we start? Where can we start? We have update function and it's empty for now. Let's just update. Let's just iterate over all the voids. Max and voids plus I. Let me grab it. If it's not spawned, we just continue. It's okay to have to have some small amount of repetition in your code. It's totally fine, especially if you're programming in C. It's totally fine. They are lying about don't repeat yourself. Please repeat yourself sometimes. It's okay. Okay, now let's implement separation force. How can we even... Well, first of all, we need to iterate over all other voids to compute the separation force from each void to our target void. Let's say g max and voids plus g, and void other void is equal to voids j. If other void is not spawned, we just continue. Or if my void is equal to other void, I also want to continue, because I don't want to separate current void from the from itself. Yes, okay. Let's maybe compute some kind of separation force. For instance, let's take the distance between distance is equal to vector 2 distance between current void position and the other void position. Let me draw a little bit. Draw. So let's say I have some kind of void. Let's say this is my target. This is my current void, yes. And I have maybe other void. And I want to compute some sort of separation force between these two voids and apply the separation force to the green one void. Later, when I iterate over other voids, I will apply also separation force to the blue one, but now I'm dealing with only green one. And I want to apply separation force. First of all, I can compute the distance between these two voids. Like so. And let's say this is D. Okay, we have D, we have distance. And this is not a vector, it's just a scalar value. I need direction. direction in which I will separate this green Boid from the blue one. And direction is simply just continuation of this vector. I want to keep the same stroke style, but it's impossible. Anyway, I don't want to waste time on this. For example, this vector. And let's say that this vector is just a unit vector. So it has length 1. Maybe it's not particularly convenient because I have distance. Let's say distance, or maybe let's say just d small and d large. D large is the direction, and it's a vector. It's a direction in which I want to separate this Boid from the blue Boid. It's a d distance. I have a distance. It's a direction. It's a vector basically. But which kind of length I want to scale this vector? Because I don't want to separate it on the unit length, because imagine that I have another Boid here, yes, and this Boid is much closer to the green one, and maybe the separation force should be much higher than the unit vector, and I want to scale this distance vector on the separation strength. How can I transform this distance? Into some kind of separation force? Well, let's maybe apply the same strategy as people use in, for example, in light attenuation, when you have some source of light, some light, and you need to compute the influence of this light, for example, on this point. And basically people use some kind of inverse quadratic formula. For example, you can inverse this kind of stuff. You can 1 plus d times d, where d is just a distance between point and the light. And imagine that distance is 0, so they basically on top of each other. In this case, this stuff will be equal to 1, because we divide 1 divided by 1 plus 0. If this distance, for example, 10, we divide 1 by 1 plus 100. And as you can see, it's approximately 0.01. So the larger the distance is, the smaller the influence is. So let's maybe compute this influence. Float distance, float influence. Influence is just 1 divided by 1 plus this distance square. And if you are wondering why do we need this 1 here, because in the case of the 0 distance, when two Boids overlap each other, we will divide by 0, because 1 divided by d times d, when d is 0, is infinity, so I don't want this kind of behavior. So that's why I add some constant term here. Okay, influence. Now let's take this direction vector, and this direction vector is defined by difference. Vector 2 direction is vector 2 subtract from the current Boid position. I want to subtract other position, this is, and normalize it, because this is direction, normalize. And now I can scale vector2, scale this direction by this influence. And this is my vector2 separation vector. So basically, I take this direction, I compute some kind of influence from this distance, and I scale this direction on this influence. And the final, let's say, the final separation force will be some kind of vector in the direction of D with scale of K. Not K, influence. And I just store this influence somewhere for now. I will apply this influence later, this influence vector later. Now let's just iterate over all other Boids and collect the separation vectors. And we just aggregate in a common separation vector. Separation vec is equal to 0 from the beginning, as the initial value vector to 0. And I just add this separation vec is equal to vector to add separation vec and this. Okay, separation vec is computed. And currently separation vec is some huge, large, long vector in the space, because if I have a target Boid and I compute a lot of separation vectors, for example, like so, from other Boids, from here, for example, and I sum up these vectors, I will obtain, I don't know, for example, I will obtain maybe, let me quickly compute the sum of these vectors. Yeah, I will obtain some kind of this one. And maybe this vector is too large to apply this shift directly to the target Boid. And also we don't want to apply the direct change of the position to the Boid. We want to behave them kinda more or less physically. So what can we do? We can treat this vector not as the change of the direction, not as the change of the position of the Boid, and even not as the change of the velocity, because we don't want to change velocity so quickly and so rapidly. We want to change the velocity smoothly. That's why we need another proxy to the whole system, and this other proxy is basically forces. So in the simplest dynamic movement case, when you have some kind of object in space, and these objects are moving by following some kind of rules, physical rules, they are influenced by forces, by the external forces or by the forces provided by other objects and whatnot. So let's transform this vector into a force. How can we do this? Well, force is basically force is defined like, if you remember from the from the basic school physics, force is simply m times a. And how can we transform this force to the position change? Because eventually we want just to change the position of the body, eventually. How can we transform this? So let's factor out the a. A is simply f divided by m. And what is the a? And by the way, this is a vector and this is a vector. this is a vector, and this is a vector. And A is acceleration. It's acceleration of the body itself. We can say that, okay, what kind of measurement units does A have? Well, it's meters per second square. We want to compute velocity. We also want to compute velocity. What kind of units does it have? Meters per square. How can we transform meters per square? Oh, sorry, meters per second, and acceleration has meters per second square. How can we transform meters per second square into meters per second? Well, we can just multiply this stuff on seconds. If we multiply it on seconds, we will obtain meters per second. So also we have some kind of dt. It's just delta time. It's just delta time between your frames, and we want kinda multiply this dt by the acceleration, and we will obtain meters per second. We will obtain basically velocity change. Let's say this is dv, it's velocity change. So if we multiply dt by acceleration, we will apply we will obtain velocity change. Okay, but finally we want to obtain change of the coordinates, change of the position. What letter should I use? Let's say S, but it's not seconds, it's large S, it's position. It's also a vector, and the strategy is the same as with velocity. It's basically dt times dv. Maybe not dv, sorry, times v. And in order to obtain the v, we actually need to apply this dv to our v. So Boid has some kind of velocity, and we want to apply this velocity. We want to apply this delta to this velocity. So it will be v plus dv and now we updated velocity vector, and we just simply can calculate the change of the position, and the measurement units of the change of the position is just meters. And as you can see, we have velocity with measurement units meters per second, and here we have measurement units just meters, because we factored out these seconds from the denominator. Okay, and finally S is equal to S plus ds. Well, frankly speaking, I don't like this S here because it may be confusing. Let me just say that it's meters divided by some time. It's just measurement units. It's just hint for myself, so it doesn't matter. Meters by time, and here we have just meters. Okay, and finally we will set this new position to our Boid. So Boid position will be equal to this new s. Okay. So let's treat this separation vector as the final force. Let's say that acceleration vector 2 acceleration is equal to force. Let's say force is equal to just separation vector. Let's put it like this for now. Acceleration is equal vector 2 scale force. We need to scale it by inverse value of the mass. 1 divided by Boid mass. We don't need mass, we need to create this property. Let's say here velocity. By the way, I also want spawn Boids. Spawn position, let me say velocity is equal to vector 2 0, and say Boid mass is equal to mass. I will just hardcode this for now. Color radius static const float mass, let's say 1 for now. Mass, yes, that's it. I computed the acceleration. Now I can compute the change of the velocity. Vector 2 velocity. I prefer to call these changes of velocity and positions like step. Velocity step is equal to vector 2 scale acceleration, and scale is dt. As you can see, here we have dt times acceleration dt. And what is our dt? dt is float. dt is equal to get frame time, not font, get frame time. It's just the difference of time between current frame and the previous frame. And it's usually used to factor out these time coefficients from your denominators. Vector 2 scale acceleration. This is velocity step. Now I can update Boid velocity. Boid velocity is equal vector 2 at Boid velocity step. Okay. Then I can compute the position step. Position step is equal to current velocity of the Boid vector 2 scale Boid velocity, and we want factor out time component from the velocity vector to obtain position delta dt position step. Okay, and now we can just change the final Boid position. Boid position is equal to vector 2 at Boid position step. That's it. Let's maybe try to run this stuff. I prefer to guess what I will see when I run some finished chunk of the algorithm, And I bet that we will see that boids will separate from each other. But maybe they don't. Let's think what we will have if the distance is 0. We will have influence equal to 1. We will have influence equal to 1, as we discussed earlier, here and here. But the direction is kind of 0 vector, because we don't have the direction when two boids basically overlap each other. So probably we won't see anything. Let's try. Yeah. they just can separate from each other, even though we have some kind of influence, but we don't have a separation vector. It's basically 0. So maybe we should add some kind of randomness when we spawn the boid. Let's say position. Let's say that position. How can we add some kind of randomness? Let me quickly create a little function which returns random float get random value, which returns random float, for example between -1 and 1. Between -1 and 1. -1 to 1. By the way, get random value. I know that raylib has this kind of function, but it returns an integer, and I need to return a float value. Get random value. Okay, let's return from 0 to int 32. Sorry, I was trying to speak Russian. Int 32 max. Where do I have this kind of? No. Include int types. Yeah. From 0 to int 32 max divided by int 32 max. And this is, let's say, float value is equal to this one. And this will provide the value between 0 and 1. But I want between -1 and 1. So I can add 1 to this value. No, I can multiply it by 2, and this will provide values between 0 and 2, and also decrease it by 1. This will provide from -1 to 1. So value is equal to this one. Yeah, and just return it. Get random value. And let's set the offset here. Get random value. For x and for y. Random value. But maybe it's too high to provide value between maybe it's too large values between -1 and 1. Let's check it quickly. No, I don't want this. Yeah. You know what? I'm forgetting to clear the screen. But anyway, this looks nice. Yeah, as you can see, they're separating, but I forget to clear the screen. I forgot to clear the screen. But this one looks nice. You can already use it. Begin mode 2D, begin drawing, clear background color. Let's say some color, static const background color. This is color is equal to, let's say let's set some dark grayish color, 2.5. Yeah, and as you can see, they are just spreading from each other. By the way, this is a good way to implement so-called blue noise. And blue noise, it's very useful in game development. It's kind of like if you want, let's say you want to place some maybe stones or trees or houses or any sort of objects evenly in some space, and you use, for example, white noise for this. White noise is simply random noise, normal distributed noise, and you use white noise for this. Well, it's not normal distributed, it's uniformly distributed, and you will obtain eventually some kind of random positions, but these positions are not particularly good for maybe for your purposes, because they may form some clusters here, for example. They may form some individually placed objects far away from other objects, so it's not particularly good. And if you want to obtain something like this, with more evenly distributed points, basically you can use this sort of algorithm. You can create points in the middle of the screen of your area and just push them from each other. And yeah, as you can see, they already flew away, but you get the idea. Yeah, you can use this sort of algorithm, but you need to restrict obviously your area and whatnot, but you can use this kind of method. Let's maybe, yeah, and now the separation is working, but now we want to restrict the Boids movement eventually, because now they are moving indefinitely. Let's say that we have some kind of damping force, some kind of damping force, and damping force is basically a force. Well, sometimes people call it maybe friction force. It's basically when you have some object, let's say let me put a small title, friction damping. Let's say you have Boid, for example, and this Boid has a velocity, for instance here. For instance, I said for instance in this direction, and it's just moving. Each frame is just moving in this direction by little steps. But I don't want, I want this, I want the Boid velocity, I want the Boid velocity to decrease each frame a little bit, like friction, for example, like friction acts in real world. It's decreasing, it decreases the basic velocity of an object. But real life friction is very complex. We will just simply say that every time the velocity is present with some kind of strength, we just simply add the inverse vector to the velocity. So we kind of damping the velocity, and the final velocity will be decreased by some amount of damping force. Damping. This is velocity after damping. How can we implement this? Well, let's go to this let me think. Let's say that also our force, well, we can apply this damping here, yes, of course, but I want to have some kind of a proxy, and my proxy will be forces. I don't want to apply direct changes to the velocity or to the position. I will say even more. I will say that this code should be fixed for all Boids, because this code is some kind of constant behavior, constant physics. Basically, this is our physics engine. It's a simple one, but it is what it is. It should be constant. That's why I want to act on in the space of forces. So let's say force is equal to vector 2 at force damping force. And what is the damping force? What is the damping force? Let's compute it. Damping force. Well, first of all, it's equal, its direction is equal to the inverse direction of the velocity. So we can just flip the velocity. Vector 2 scale Boid velocity, and we just flip it. We can scale it by -1. Yeah, but if we apply it like so, we will effectively no, velocity won't be 0 in this case, because it's a force with the length of the velocity. Maybe we should scale it somehow, but let's try it for now. Let's try this for now. Yeah, it's perfect. I think it's perfect. This is a separation force. Yeah, but anyway, we want to have control over the behavior of the Boids, because as you remember, we have these 3 basic forces, and eventually we want to balance between these 3 forces. So let's maybe introduce some kind of coefficient. First of all, let me say vector 2 separation force is equal to vector 2 scale separation vec, and we want to scale separation vec with some kind of coefficient, and this coefficient belongs to Boid itself. So it defines the Boid's behavior. So Boid, let's say separation score, or maybe separation tendon. Let's say it's separation score. Separation force. We have damping force. We have separation force. And let's say we have vector 2 net force. It's just a summation of all the forces. And we will start with damping force, and then we will simply add all other forces. Separation force. Here is net force, and we need to define separation score for each Boid. So let's say float separation score. Also, for now, we can make it constant for each Boid, the same for each Boid. Static const float separation score is equal to 1, for example. I have mass, I have separation score. Separation score is equal to separation score. Separation score. Am I recording? Am I recording? Yes, I am. Separation score. Let's try. Let's try. Okay, and now I want to show you how we can influence the behavior of the Boids. For example, let's say let's set separation score like 10, for example. Yeah, and as you can see, they are flying away from each other on much further distance. I kinda love this pattern. It's so cool. Okay, let's set it maybe 0.1, maybe a little bit larger, 0.1, and I want maybe decrease the radius of the Boids, like, you know what, I think radius 1 is okay. Maybe I just increase zoom, or I should say decrease zoom. No, maybe 3. Yeah, maybe 3, and increase separation score 0.5. Yeah, maybe it's fine. Maybe it's fine. Okay. I need to make a small break, maybe 5 minutes, and then I continue.